Kairos mentioned that Fred Lasky, director of MWRA, was the next speaker, but Fred has yielded his spot to Stephen Estes-Smargiassi, who is the Director of Planning and Sustainability for the MWRA, which I guess makes a great deal of sense for Stephen to be doing this. I had a nice conversation with him before we started. He's been with the MWRA for 27 years. His current responsibility is to assess the vulnerability of the MWRA's facilities to climate change and to explore ways that it can adapt to those vulnerabilities. Stephen.
Thank you. So after some very broad scale and very imaginative looks by Daniel and Kairos at whole cities, I want to narrow our focus a little bit and talk about pragmatic, practical approach to a single piece of infrastructure, but perhaps with some real life examples of things that are currently underway. Mostly what I'll be talking about today is adaptation, but I think it's important to recognize that as a public agency and as part of both the problem and the solution to climate change that we need to focus on mitigation as well. We have a fair amount of effort underway to reduce our greenhouse gases, contribute to the common good, and perhaps also improve the public's perception of us. We are the regional wholesaler. We provide water and sewer services to 61 cities in the Boston region. About 200 million gallons per day of drinking water supply. Before I proceed any further, I'll mention that in 1980, we used 340 billion gallons a day, and some of the lessons we're trying to apply now to climate change and our efficiency of energy use come out of our success at reducing water use down to substantially below our reliable yield. And then on the wastewater side, we have one of the largest wastewater plants in the country, processing up to 1.2 billion gallons per day on a rainy day, perhaps like this morning, when our flows jumped up quite substantially while I was getting out of bed. So I like to think about, you always need to know what your mission is in order to know where you're proceeding, to know what you're doing. And you can use a lot of words or you can really boil it down. Drink with confidence. I think John Sullivan kind of framed that earlier. Flush with pride. If we're going to have a clean harbor, we want people to realize that they're connected to that harbor. Those are both nice three-word slogans. Being in an agency that's spent about $7 billion in the last 28 years, I like to add all accomplished affordably in order for us to retain our independence and our ability to do these good things. Our customers need to be comfortable that they can afford our services. And as we think about climate change, our customers do expect to be able to drink with confidence and flush with pride under all circumstances. It's not just a good sunny day situation. So let me start with Deer Island. Deer Island's the largest plant in one of the largest plants in the country. And it's one of the few places where we have actually done anything nationwide concrete. When this plant was being designed in the late 1980s, the engineers, in almost a guerrilla action, looked at sea level rise. They looked out 50 years from 1989 with the best available science and added to the Deer Island an assumption that the sea level could rise almost 2 feet. Might not be what we would pick today, but it was a pretty good number back then. And they did a bunch of things. Physically, the island is armored to assume storm surge and that sea level rise. The island assumes that the grid will go down, that our partners, as New York experienced, and some of our partners in the electrical generation will lose their ability to deliver power to us. We can be freestanding for an extended period. And our principal headworks supplying the south of the system is also similarly armored. So the facility itself is adapted to climate change. More interestingly and more importantly, and really where they got started on it, is that hydraulically we have the capacity going forward. If you think about how almost anything in the water and sewer industry works, it's elevation differences. The plant's here, sea level's here. The difference between those two things is what allows us to take the wastewater from the plant and move it 9 miles out the outfall to discharge way into Mass Bay. If sea level rises, the capacity of the outfall goes smaller. If the capacity of the outfall is smaller, the capacity of the plant is smaller, and it rains, and we're discharging untreated wastewater closer to where people live. That's not our mission. Our mission is to get it, take it away, treat it, put it out in the harbor. So the plant was raised hydraulically, the whole plant was raised almost 2 feet, and the outfall was built slightly larger. So the plant, the biggest piece of our infrastructure, biggest single piece, was adapted to climate change before it's constructed. So that's great. Physical, something done. What else have we looked at? We've been thinking about this for almost that amount of time in the rest of the system, and I like to show this because it shows a little bit about how long we've been at it and how the science has changed. When I first started looking at climate change for the water system in the early 1990s, I could get a single precipitation data point and a single temperature data point per year for that grid cell. Now, there's Massachusetts. This is the Canadian Maritimes. I think Washington, D.C. is down here somewhere. We know that those places are not alike. Now, we can get data broken down into many smaller grid cells, and in fact, out by Worcester, where our reservoirs are, where it rains and snows differently, has a different value than here in Boston. So we're able to do that. We're also able to look at multiple models and get some sort of statistical view of how the weather might change in the future. So now we have weekly data at that kind of scale and are able to use that. So what does it give us? So John Sullivan mentioned that we've got gravity to move the wastewater in the metropolitan area. I'm here to say that not only will gravity move it, but as climate changes, we've realized that the foresight of the folks who designed our system, very large reservoirs compared to their watershed, means that although we'll see much more variability in precipitation, wetter wets, drier dries, in fact, we can capture that increased precipitation, and we expect to see not a degradation in our ability to supply water, but a slight increase. That's great because many of our neighbors, Cambridge and others included, are likely to suffer from those drier dries and come to rely on us more heavily periodically, and we need to build that into our long-term planning estimates. That's the supply. It's nice to know that, in fact, the reservoirs will stay standing. Sort of worst case analysis for a water supply person is that your dams go away in a major storm. We've put a fair amount of investment into that, looking at not just what the current version of dam safety would look at, but thinking a little bit about climate change, and have really convinced ourselves that we're in pretty good shape there with the investment of a fairly substantial amount of money in the recent past. One of the things we've tried to do as we've looked at investments for climate change is to make sure that we're getting the maximum benefit in day-to-day flexibility and resiliency. It's nice to know that an investment in something like dam safety is great for something that might happen 20 or 40 or 50 years from now, or might have a probability of one in 500 years. It's even better to know that it makes it easier to operate that facility today. So we're thinking in each one of our investments, what can we do to get benefit today as well as benefit long term? In this case, by adding more flexibility to the way in which the dam operates, a gate at the top which we can lower and raise, we can now operate the reservoir for environmental benefit, flood control benefit, and water supply reliability in ways that the original designers had not planned for. Great investment, long-term vision, short-term benefit as well. So let's switch a little bit to the metropolitan Boston area. Let's switch a little bit to coastal stuff. We all know, you've all seen 6 or 7 versions of this stolen from somebody else's presentation. Sea level is rising. We've seen it. Big storms, Sandy, got our attention. So, a great crisis for many folks in the Mid-Atlantic states. My family's from New Jersey, several weeks without power. My son was in Hoboken. Got to sit on the top of the hill and see everything flooded. But for us up here in New England, it offered a couple of good lessons. There's, the famous data from New York, multiple tide cycles. Here in Boston, when we look at the data, what I draw from it is 4 or 5 hours later, and this storm would have been worse than the storm of 1978. We would have seen substantial damage. So it got our attention. I like to say my attention is already captured. In Charlestown Navy Yard, just around the corner from here, sea level rise will make it a little difficult to get to the office, at least by normal transportation modes. So what are we doing about that? So we started thinking about the Boston area and realized the great wonder of gravity is that everything flows downhill and it ends up on the coast. So wastewater from the entire metropolitan area is trying to get to Deer Island, and it ends up at facilities along the coastline. And 21 of my critical wastewater facilities sit pretty close to the water's edge in tidal areas. So we've concentrated in the last couple of years looking at those things. Here's some pictures. My boss likes pictures. Some maps. He also likes maps. These are areas where if some of those facilities went out, would be immediately in danger of having wastewater backing up. If it went a little longer, we'd see wastewater backing up into all the coastal waters and into areas in the center city. So big deal. Pictures of facilities again. So what did we do? We looked at New York and said to our board, we don't want to do some of the things that happened. Now, what happened in New York, some of it was great. Water facilities, Long Island, a lot of folks out of power. I think the number was 90% of the folks. No power. If your emergency generators don't work or don't work long enough, you're very quickly out of water infrastructure. Something we paid attention to. New York City, gravity, good system, great stuff. The water was flowing. Passaic Valley across the water in New Jersey went for quite a long time, many weeks into months, discharging relatively, first untreated and relatively untreated wastewater in the bay. That's not acceptable from our board of directors' perspective. It's not acceptable from the city of Boston's perspective, having relied on the Clean Harbor to put all that investment in place. So we don't want to be there. So we picked some benchmarks. I think John Sullivan said no design criteria. This is the only picture with design criteria. I took a fresh look. Our team took a fresh look at the 100-year floodplain. Interesting to find out that, in fact, maybe we should have been paying closer attention to those maps in the recent past. And then we picked a number. Just like everyone else, you got to pick a number. Your engineers want something. We picked 2.5 feet. A number of organizations in the area have used that as a reasonable number. It's a wrong number. All numbers are wrong. It's a good number to start with. And we also looked at some of the hurricane modeling to see how the slosh model might affect some of our facilities. And where we're very close to the water's edge, we looked at wave action as well. So I'll flash through a couple of pictures of facilities, a couple of lists here. So 6 of my facilities are close enough to the 100-year floodplain that, in fact, I should worry about them. And why do I worry about them? Because that's a made-up number. You know, 2 inches this way, 4 inches that way, and some of these facilities might be vulnerable. So let's look at each one of those. In fact, this top one here, we'll see in a minute, is actually substantially below the 100-year flood. I haven't quite figured that one out. Predates me. 18 facilities, or rather 12 facilities, getting us up to 18, including 3 of my administrative facilities, when I move the benchmark to 2.5 feet above the 100-year flood, are in trouble, or potentially in trouble. We need to look closely at those. And then fortunately, another 7 facilities, really only the worst case hurricanes. Maybe if we have the biggest hurricane taking that left angle hook at the right time of day could affect these facilities. Lower priority, need to take a look at those. And then fortunately, my 2 biggest investments, Deer Island and Nut Island, at the very bottom of the list, well protected. So gives us a sense, our board of directors and our staff, a sense that at least our biggest assets are well protected and a sense of priority to move forward. So let's look at a little bit on the map, again, because my boss loves maps. The facilities that have the highest risk there, scattered a couple up in Chelsea, a bunch more in Chelsea, and then all up and down the coast that could be affected if we raise the threshold to 2.5 feet of sea level rise. Facilities unlikely to be affected except in worst case storms. Facilities that I'm pretty comfortable, and then just for fun, the fact that I'm not worried about any of my Metro Boston water facilities. So what's that look like on an individual facility basis? Oops. So we've looked at individual facilities. And New York City, by the way, has a great, if you go to their city DEP website and look at their recovery plan, they have a great set of drawings on all of their facilities. We stole some ideas from them. These are great things to do. So here's what we have. Here's an individual facility. This is my worst facility in Chelsea. It's called the Chelsea Screenhouse. And what do you see on this photograph? In blue, this is what I'll call my critical elevation. It's the door threshold. The The water's above that, it's coming in the door. The yellow line is the 100-year flood. You'll notice it's above all the doors. If you come up to the red line, adding 2.5 feet, it's above all the windows. This facility's in trouble from the outside. More interesting is that, as John Sullivan showed earlier, when the streets flood, the sewers will flood. All the interesting things in this building are down deep and connected to things which are connected to the Chelsea River nearby. So we're looking closely at not just how do we protect it from the outside, but how do we protect it from the inside, from water that wants to normally be flowing through the facility, but in a storm might want to fill up from inside. And here's a case where the engineers did a good job, but we need to look at it again. This is the emergency generator facility. There's the benchmark. Clearly they got the benchmark right. There's the 100-year flood. And it's 2 inches roughly between there and the bottom of the generator. Not too bad in still water. You know, you get a benchmark, you meet it. But if you raise the benchmark up a couple feet, that generator's out of service. So if we want to protect this, we're going to have to do something about that. So let's switch to a facility that's in a little better case, a little bit newer facility. This is the Braintree-Weymouth pump station serving some of our suburban customers. And again, in this case, you don't see a yellow line because it's well above the 100-year floodplain. Blue's the door threshold, and red is the 2.5 feet above the 100-year flood. And then inside, so outside, we'd have to armor this. But inside, if we don't armor it, there's all this electrical equipment that's in danger. So I'll come back and talk about that in a minute as we think about what we could do. And then, just because everybody likes animations, I'm going to show this one quickly. Here we are. My Chelsea headquarters, where 500 of our staff are located and work out of every day. Our Chelsea maintenance facility, where all of our maintenance people and all of our spare parts are stored. And then the facility we just looked at, the Chelsea Headworks, in a Screenhouse nearby. Here we go, flooding coming up. You can see the ticker here. They'll turn red as they flood. Interesting, this is a good thing to do. Long before our facilities over here get flooded, I can't get there. So it really doesn't do me any good that the designers design those facilities to be above the floodplain, because it doesn't matter that all my equipment is in here. It's not going anywhere. So I need to think about that. And then worse yet, of course, if you let it flood a little deeper now, going into sea level rise, we eventually end up with all those facilities being interior flooded. So not so good. Couple of quick shots. Again, you can see one of the fun things about engineers, you give them a benchmark and they do a good job. This facility, all the way around the building, sits in an island at the 100-year flood. The parking lot's full, but the building is safe. But if you go to the 2.5 feet above that, it's flooded. A couple different angles you can see all the way around. We looked at these to figure out where all of the pertinent facilities are that could get into the building. Manholes in the parking lot and so on, emergency generators. All right, so what do we do about that? Currently, we're a water and wastewater agency. We think about rain all the time. Everybody in organization's got a weather app on their phone. I get like 25 emails a week from the weather service. If there's this morning, I got emails saying, oh my God, it's gonna rain. We think about weather. So what do we do now? Well, normally, anytime there's a significant rain, we're out there. Our staff are out there working. Facilities are sandbagged. If we don't have a built-in generator, mobile generators brought to it. Places like Deer Island, which might be cut off, staff are brought in. So we have electricians and mechanics on duty brought in so that if the island's cut off because the causeway is flooded, they're already on site. We bring emergency power up. We're ready to do this. That's what we do every time there's a big storm now. Probably not good enough. So what are we looking at? So you saw some of those critical facilities. Short term, each one of those now has a plan for short-term armoring. Where do we sandbag it today to do a better job? Interestingly, a systematic look. My boss, the director of operations, said, we argued about which ones were highest risk. I said, well, no, I got the maps. This one's worse than that. He would have sent the crews to the wrong place because he had a perception that it was a higher risk. Analysis helps with that. So we now know where to send the crews first, where to send them second, and we've got plans in place to deal with those. Longer term, what do? Well, we need to look at each facility. We've got maintenance stuff lined up now to do short-term armoring, gates in front of doors, maybe some more secure windows on certain facilities. additional plans. Longer term, we're looking at each individual facility as it comes up for rehabilitation. Pragmatic approach. Every single one of these facilities with moving parts gets renovated on a cycle of something like 20 to 25 years. They don't last long handling wastewater. There's a lot of wear and tear. You're in there regularly. So what we're doing is we're looking at that cycle and saying, is it a high-risk facility? When will it next be renovated? Is that an appropriate time to spend money on it? We have 3 facilities which were already in rehab contracts a year ago. All 3 of those have had the design contracts amended, and the benchmark has been raised 2.5 feet for the designers to look at. Outside facilities, we're looking at a variety of things. We're not buying these, but they're really cool. They're called tiger dams. You fill them up with water, and you can easily basically build a barrier around something. My view of it is they're bright orange, and you will fill them periodically when it doesn't rain. And our facility in Chelsea is immediately under the flight path for the traffic helicopters. I don't want to have those out on a sunny day. So if we do something to armor that facility, it's not going to be bright orange and like that. Be a little more subtle, because you only get twice to get it wrong before you're never allowed to do it again. This is a facility down in Quincy. We don't own it. It's our next door neighbor. This door here has provision for stop logs on either side, and that is a submarine door, sealed. These folks have an expensive robotics facility there. They don't want the storm to come in. This, for those of you who are Boston area residents, is the Fenway T-stop. Who remembers 1996 and the Kenmore Station? Who knows how much it would have cost to have avoided $85 million and 2 months worth of service disruption? About that much. That's about maybe $500 worth of lumber, which should have been there. It was designed originally when the portal was first built, but had been taken away. No one in operations knew that they were supposed to deal with it. Now there's these nice bright yellow things, they're all padlocked. And I hope, is there anybody from the T here? I hope that they're out there on a regular basis practicing. But that would have saved $85 million, simple lesson. So we're looking at things like that for all of our facilities. Here's a facility that doesn't read real well, at least from my angle, but we're looking at this facility. What can we move from downstairs to upstairs? Where can we move the electrical panels so they're above the flood? Can we split a pump so the electrical part of the pump is upstairs and the mechanical part is downstairs? Are there parts that we can sacrifice? In this facility, it'd be very difficult to move the dry weather pumps out of the downstairs, an enormous expense. But we've looked at it and said, well, we could sacrifice those. We can use the wet weather pumps, very inefficient, but we could use the wet weather pumps during normal operation until we replace the dry weather pumps. So that's the decision we're going to make. In the emergency generator, we can raise it, I think they said like 19 inches inside the building envelope, so they're going to do that. Maybe at some future date when the roof is being dealt with, they'll raise it again, but we're not going to replace the roof over it. So in each case, we're looking at the benchmark and being pragmatic about what sort of protection we're putting in place. A couple of other examples. Here's a good news. This is from this picture from New York City with a flap gate in front of a garage door, protecting that garage door. Here's a case where the mechanical equipment in one of our facilities downstairs, electrical equipment upstairs, and the nut island where the armoring around the island protects it. Think about inundation, plan for it. What else do you need to do? You need to think about that access. I showed you the Chelsea facility with the loss of access. So we're actually working on this. In fact, tomorrow, we're doing our first drill on evacuating that facility. We've got 300 vehicles, we've got 500 staff there. We're not moving them all, but we're moving some of them, and each unit is moving a few of their vehicles to their designated safe high ground area where they would be stationed in a major flood. And we've recently we have our operations center where all the computer equipment is that operates the whole metropolitan Boston sewer system and water system. We actually have moved, created a second facility out in Marlborough, well upland, far away from the coast. It's in the room adjacent to this. This is actually the treatment plant operations center. And most importantly, once a month, folks have to drive out there and practice. Why? Because you need to know that they know where it is, and you need to know that they know how to make the transition from one to the other. You don't want to do that in a crisis. You want to do it in practice. You need to practice if you're going to perform well in a crisis. what does this say? This says basically that we're using our normal master planning process. We do not have a straightforward, single-purpose climate change adaptation plan that freestands. It's built into our normal master planning. It's part of our we have lots of low probability, high consequence events that we deal with lots of opportunities to add resiliency as part of the master planning process. And that's how we're doing it. How am I doing on time? A minute or two. I'm going to just show one slide here. We're paying a lot of attention to renewable energy, and then I'll stop there. About half of the power, half of the total energy need at Deer Island comes from renewable energy, the equivalent of about 5,000 barrels of diesel fuel for heating. About 25% of our electrical demand is met on island with renewable. Half the power we use to run our water treatment plant out in Marlboro comes from renewable, and we are doing a wide variety of things around the service area, both to increase efficiency and to add renewable power. It's great to adapt, but you also need be part of the mitigation for the problem, so that those projections that lots of folks showed for 2100 that have a lot of variability, that we get the low end of variability. So with that, thank you.
Thank you very much, Stephen. You can let Fred know, if he doesn't already, that he's got the right guy in charge.